Hello everyone, this is Manohar. Today in this presentation, we discuss about the topic machine learning and deep learning for natural language processing. Introduction to NLP. NLP is the field of computer science that deals with the interaction between computers and human languages. Machine learning and deep learning are two powerful machine learning techniques that are being used to achieve significant advances in NLP. Machine learning and deep learning can be used to develop NLP models that can perform a wide range of tasks such as machine translation, text summarization, questions answering, sentiment analysis, named entity recognition, natural language interference. Machine learning and deep learning are both types of machine learning that may differ in their approach. Machine learning algorithms are typically trained on a set of labeled data, meaning that the data is already associated with the desired output. For example, in machine learning algorithm could be trained on a data set of sentences labeled as either positive or negative sentiment. Once the algorithm is trained, it can be used to predict the sentiment of a new sentences. Whereas deep learning algorithms, on the other hand, are typically trained on the unlabeled data. This means that the data is not associated with the desired output. Deep learning algorithms learn to perform tasks by finding patterns in the data. For example, deep learning algorithm could be trained on a dataset of text and code. The algorithm would learn to identify patterns in the code, which it can then use to generate new code. Natural language processing, a fascinating intersection of artificial intelligence and linguistics. NLP is all about enabling machines to understand, interpret, and generate human language, making our interactions with machines more natural and intuitive. The applications of NLP are vast, encompassing machine translation, question answering, summarization, and much more. Now let's talk about the role of machine learning in natural language processing. Machine learning is playing a major role in advancing the field of natural language processing. By enabling NLP systems to learn from data and improve their performance over time, machine learning is making it possible to develop NLP models for a wider range of tasks with greater accuracy and efficiency. Overall, machine learning is a powerful tool that is being used to transform the field of natural language processing. By enabling NLP systems to learn from data and improve their performance over time, machine learning is making it possible to develop NLP models for a wider range of tasks with greater accuracy, efficiency, and personalization. Introduction to deep learning. Deep learning is a subset of machine learning, takes this a step further. It refers to machine learning technologies that learn and utilize deep artificial neural networks. These include deep neural networks, convolutional neural networks, and recurrent neural networks. Deep learning has been a game changer in several NLP tasks such as classification, matching, and translation, often outperforming traditional approaches. Deep learning approaches can also eliminate the need for task specific feature engineering and train end to end models for various NLP tasks. Advantages of deep learning. There are numerous advantages of deep learning in natural language processing. Deep learning have the potential to revolutionize the finance industry by improving fraud detection, risk assessment, investment research, and customer service. In fraud detection, deep learning can help to identify fraudulent transactions and activities by analyzing financial data and text communication. For example, DL can be used to analyze credit card transactions and identify partners patterns that are associated with fraudulent activity. The model can also be used to analyze customer emails and social media posts to identify customers who may be at risk of fraud. In a risk assessment, deep learning can help financial institutions to assess the risk of lending money to borrowers by analyzing their credit card history and financial statements. In investment research, deep learning can help investors to research investments by analyzing financial news and reports. For example, deep learning can be used to identify news articles that are likely to impact the stock market or to identify industry reports that may contain valuable insights that potential investment opportunities. Customer service. Deep learning in customer service can provide better customer service by understanding the sentiment of customer feedback and by identifying customer needs. For example, deep learning can be used to analyze customer reviews to identify common problems and understood how customers are feeling about the financial institution's products and services. The model can also be used to identify customers who may be at risk of churning and to develop strategies to remain them. Machine learning and deep learning challenges in natural language processing. When we go deeper, we find that deep learning, despite its strengths, might not be sufficient for interference and decision making. The deep learning and machine learning challenges are data requirements, bias and fairness, interpretability, limited generalization ability. For example, in deep learning, the data requirements, that is, machine learning and deep learning models, are trained on data. And the more data they are trained on, the better they tend to perform. However, collecting and labeling large amounts of high quality NLP data can be expensive and time consuming. Additionally, NLP data is often noisy and ambiguous, which can take it very difficult for machine learning models to learn accurate patterns. Bias and fairness. Machine learning and deep learning models can learn biases from the data that they are trained on. If the training data is biased, the model will learn to make biased predictions. This is a particularly important concern in NLP, where the data can reflect the biases of the people who collected and labeled it. Interpretability. Machine learning and deep learning models are often black boxes, meaning that it is difficult to understand how they make decisions. This can make it very difficult to debug models when they make mistakes, and it can also make it difficult to trust the predictions of the models. Limited generalization ability. Machine learning and deep learning models are typically trained on a specific task and dataset. When applied to a new task or dataset, the model may not perform well. This is because the model have learned to exploit specific patterns on the training data that are not present in the new data. Despite these challenges, machine learning and deep learning are rapidly transforming in the field of natural language processing. As researchers continue to address these challenges, we can expect to see even more innovative and powerful machine learning based NLP applications in the future. Overcoming the challenges. So, how do we overcome these challenges? Hybrid models that combine rule based statistical and neural approaches are one of the reasons to overcome these challenges. Additionally, developing techniques to identify the migrate biases in NLP models is crucial for ensuring fairness and accuracy. So, one way to overcome these data requirements of machine learning and deep learning models is to use synthetic data. Synthetic data is artificially generated data that can be used to train machine learning and deep learning models without the need of to collect and label real world data. One other way to migrate bias in machine learning and deep learning models is to use debiasing techniques. Debiasing techniques can be used to remove biases from the training data or to modify the training process to make the model less susceptible to bias. By addressing these challenges, we can continue to advance the field of natural language processing and develop machine learning and deep learning models that are very powerful, efficient, and reliable. Now, from the next slide, my teammate Jashwanth will take over the presentation.
Uh, this is Jashwanth. Now we are discussing about the case studies here. Various case studies showcase the successful implementation of machine learning and deep learning in NLP. Benchmarking these against traditional models provides a clear picture of the advancements made and the potential for future innovations. This slide provides our information about future trends, namely continued evolution of deep learning architectures, advancements in unsupervised and semi-supervised learning approaches, and also applications of machine learning and deep learning in NLP. If you elaborate this topic, deep learning has revolutionized many fields in recent years, and data structures are no exception. Deep learning based data structures are often more efficient and accurate than traditional methods, and they are becoming increasingly popular in wide range of applications. Um, Advancement in unsupervised and semi-supervised learning approaches increase becoming increasingly important as the amount of unlabeled data continues to grow. These approaches can be used to learn how data without the need of human labeled examples, which can be very time consuming and expensive to obtain. Applications of machine learning and deep learning in NLP, like natural language processing, is another field that has been transformed by deep learning. Deep learning based NLP models can now perform a wide range of tasks such as machine translation, text summarization, and sentiment analysis. This is leading to new applications of data structures in NLP, such as the development of more efficient and accurate algorithms for text indexing and retrieval. Now, the applications of machine learning and deep learning in NLP. The applications of machine learning and deep learning in NLP span across various industries, including healthcare, finance, and education. They have a real world impact, enhancing customer experience and improving accessibility, making a tangible difference in our daily lives. The slide explains the most important ethical considerations in machine learning and deep learning. There are bias and fairness, privacy and security. When we talk about bias and fairness, machine learning and deep learning models are trained on data, and this data can reflect the biases of the people who collected and labeled it. For example, if a facial recognition model is trained on a data set that contains mostly white faces, it may be less accurate at recognizing faces of people of color. It is important to address potential biases in machine learning and data and deep learning models to ensure that they are fair and equitable. This can be done by using techniques such as collecting diverse data. Um, Machine learning and deep learning models should be trained on data that is as diverse as possible. This will help to reduce the risk of model learning biased patterns and identifying and mitigating bias. There are a number of techniques that can be used to identify and mitigate bias in machine learning and deep learning models. For example, one technique is to use adversarial training, which involves training the model on data that is specifically designed to expose its biases. And another one is evaluating fairness. It is important to evaluate the fairness of machine learning and deep learning models before they are deployed in production. This can be done by using metrics such as accuracy parity, equal opportunity, and fairness through awareness. The other consideration is privacy and security. Machine learning and deep learning models often process sensitive data such as personal information or medical images. It is important to ensure that this data is protected from unauthorized access and misuse. Some of the ways to ensure privacy and security in machine learning and deep learning include using an anonymized data when possible. Machine learning and deep learning models should be trained on anonymized data. This means that the data should be modified so that it is possible to identify individuals from it. Using encryption, data should be encrypted when it is stored and transmitted. This will help to collect it from unauthorized access, protect it from unauthorized access. Using secure development practices, machine learning and deep learning models should be developed using secure software development practices. This includes things like input validation and error handling. In addition to the two ethical considerations mentioned in the slide, there are a number of other ethical issues that need to be considered when developing or using machine learning and deep learning systems. These include transparency and accountability, human oversight, social impact, these kind of things extra. By carefully considering all these ethical issues, we can help to ensure that machine learning and deep learning models are used for the benefit of society. That's it. So, in conclusion, machine learning and deep learning play a pivotal role in advancing NLP, or opening doors to numerous possibilities. The journey ahead is filled with potential for further advancements and areas of research that could redefine how to interact with this technology. In the slide, we placed some of the references that we gathered information, and so that's it. This is our presentation. Thank you.